Okay, so let's look at problem number 1. So in this case, what we want to do is we want to take our given function and we want to translate it 4 units left. I'm going to put a little 4 here. I don't know why I spelled out 4. That was kind of silly. So I'm going to translate it 4 units left, and then I'm going to shrink it vertically by 1/3. So there's 2 moves. Translate left 4, then shrink vertically by 1/3. So let's translate the graph left 4 units. So here's our graph. Here's our function. In order to do a horizontal translation, right, because we are moving left, that's a horizontal translation, what we are going to do is we are going to manipulate h. So it's going to be x minus h. Okay? And our job is to plug in our number for h. So let's go and do that. In this case, see if you agree with me, we are going to plug in, if we're going 4 units left, we're going to be plugging in -4 for h. So I'm going to replace h with -4. When we simplify that, right, x minus a -4, we get x plus 4. Okay? So this represents right here, this represents us translating the graph 4 units left. So reminder, what we do is we take the stuff in the parentheses, and wherever we have x, we replace it with the stuff in the parentheses. So in other words, what we get is we get 3 times x plus 4 plus 5. Again, all I did was take the stuff in the parentheses and substitute it in for x. Okay? The next thing we're going to do is we're going to shrink it vertically by 1/3. So what that means is we're going to take our function. I'm going to give myself a little space here. So I'm going to take, because it's a vertical shrink by 1/3, I'm going to take 1/3 and multiply it to the function. This represents the entire function. So I have to take 1/3 and multiply it to the entire function. So in other words, I have to take 1/3 and multiply it to the entire function. So when I'm finished, my function is going to look like this. I'm going to rename it. I'm going to call it g of x. So I'll say g of x equals this stuff. You don't have to, but it's just shorter. I'm going to say g of x, our new function, equals, well, I'm going to distribute that 1/3. 1/3 times 3 is 1. So x plus 4. And then 1/3 times 5 is 5/3. Notice how we had to take that 1/3 and we had to distribute it to both because we're multiplying it, that 1/3, to the entire function because it was a vertical translation. A vertical shrink. Okay? Let's move on to the next one. So in this one, we are asked to write the equation for the line below. So normally we'd like to use y equals mx plus b, but we need to know the y-intercept, and I don't know what this value is. I can approximate it, but I don't know what it is. So instead what I'm going to do is I'm going to use point-slope form. In point-slope form, we get y minus y1 equals m times x minus x1. So I need to know a couple things. I need a point. I have 2 of them, so the point stuff is covered, right? I have a point. I have 2 of them, so my point is covered. What I don't have is I don't have a slope. So I am going to go and find the slope. And the way we do that, right, is we use our formula. So the formula for slope is m equals y2 minus y1 over x2 minus x1. So for the point, what I'm going to do, let's see what our points are. We have these 2 points right here. Let's write those points down so we can refer to them. So the first point is the point, what is this? This is 540. And the second point, this is 750. So plugging this into our formula, we get y2 minus y1, which is 50 minus 40, over x2 minus x1, which is 7 minus 5, which equals 10 over 2, which equals 5. So our slope is 5. So now we have a slope and we have a point. Either one of these two works. So I'm going to plug everything into this formula. So let's see what we got. So I get y. I'm going to use, since I have a choice, I'll just use this one. Okay? So y minus y1, which is 40, equals m. We already found m above, times x minus x1, which is 5. From here, I'm just going to clean it up a little bit. Put it in slope-intercept form. So y minus 40 equals 5x minus 25. Y equals 5x. Add 40, so that should be 15. Okay, so the first thing they asked us to do was write it, write the equation or line, which we've done. So I'm just gonna highlight that. We did that. Okay. The next thing they asked us to do was interpret the slope and the y-intercept. So let's start with the slope. So for our slope, remember what we do is I'm going to take the number that we found and I'm just going to turn it into a fraction. So our slope is 5 over 1, and I'm going to include the units. Okay, so these are our units. In this case, our units are our y units are pounds, and our x units are years. So what this is saying, our slope is saying that this child's weight, it's increasing by 5 pounds per year. I imagine, by the way, that doesn't make any sense whatsoever, because I imagine that doesn't make any sense whatsoever. So don't go by, don't worry about whether it makes sense or not. It is what it is. So by our formula, this child is gaining 5 pounds every year. So 5 pounds per year. That's what the slope represents. Now let's talk about the y-intercept. The y-intercept, right, is where it crosses the graph. That's this number right here. It tells us at time 0, it's giving us our time 0, so the initial weight is 15. So the y-intercept represents, we could say, the birth weight of the child. Which is 15 pounds, which is really big. Again, maybe not realistic. Okay, I'm going to stop here. See you in the next video.